Bismillahirrahmanirrahim. Welcome students. Previously we started article 3.2 and today we will continue that article. Today we will distinguish between mass and weight and I will be giving you a small home assignment. Starting with mass and weight. Matter contained in a body is called mass. So mass of an object. Mass of an object means that the number of atoms that are present they constitute the mass of an object. For example, a book, in a book, the number of atoms that the book is made of constitutes the mass of that book. What about the matter contained in our body? Let's see, matter contained in our body. Okay, digestive system, circulatory system, bones, muscles, fat, liquid. This all constitutes This is all the matter that constitutes our body and makes up our mass. So that is the mass. And what is weight? Weight is the force with which the earth attracts a body towards the center. So simply, it is the force on us due to the pull of earth's gravity. Hmm. Okay, so gravity is acting on us. So basically, weight is a force with which we are being attracted to the earth because of gravity. You know, gravity is pulling everything towards it. There is a huge misconception between mass and weight. People do think mass and weight are alike, they are similar terms, but they are not. Actually, truly, they are not. Mass is just the matter contained now, by definition, you now know, and weight is just the pull of Earth's gravity on us. So they are two different physical quantities. And I would definitely like to know the answer to this question, which I'm sure you will be able to answer at the end of this lecture, that what is a weighing scale measuring? If you are standing on it, what is it measuring? Is it the mass or is it the weight? What does the weighing scale measure? And I'm sure after the lecture you will be able to answer and you will be definitely clear with your concepts. So basically the picture over here, you can see the mass and weight. You can see that the gravity is acting on it in downward direction. That is the weight. The SI unit of mass is kilogram. SI unit of weight is Newton. Okay, so mass of a body remains constant everywhere, whether it is measured at a point far away from the center of the earth or on the surface of the earth. Yeah, that's true. Mass of body remains constant. So suppose you're planning a trip to go to the moon. Obviously, since there is no McDonald's, you're not going to leave your digestive system behind. you, you will definitely, yeah, you will. If your mass on Earth is 50 kg, that will remain the same on moon and in space. Yes, it will not change. And the weight of the body is not constant quantity as its value is different in different places because we know that the gravitational pull of Earth is acting on our body. So whenever we are measuring the weight, uh, we are actually calculating the pull of gravity, the force of gravity on our body, on our mass. So it is not a constant quantity. And you know, gravity is very strong on Earth. We feel this gravitational force on us very strongly when we are on Earth. And as soon as you move away, that is, you go into space, you have seen astronauts flying in the air, floating in the air, not flying, floating in space, because there is no gravity. On moon, you might have seen in different movies, they are jumping on the surface of the moon because of less gravity. So value of G decreases with height. Yes, gravity decreases with height. And when gravity decreases, it means since gravity and weight are related together, so when gravity is decreasing, it means value of G is decreasing. It means weight is also decreasing. The picture over here, this Earth and Moon, a person standing. Yes, mass, if you can see, is same whether he is on Earth or on Moon. However, weight is changing. You can see the value because of the gravity. It's 500 Newton on Earth and it's 80 Newton on Moon. There's a formula to calculate the weight, that is W is equal to mg. Right now, we will definitely be discussing it, and then you will know how we calculated 500 newtons and 80 newtons. Yeah, and it's all because of G. Yeah, and then this all is because of G. Mass is a scalar quantity. Yes, it only gives you the magnitude. Yeah, and weight is a vector quantity as it requires direction as well as magnitude. Yes, you do get the magnitude, but direction, we are feeling, and the force of gravity, it is directed towards the center of the earth. So weight is directed towards the center of the earth. Yes, downward. Mass is measured by beam balance. We did discuss beam balance in detail in chapter 1 when we were doing mass measuring instruments, but still, yeah, I'm going to discuss it. This is the beam balance. You can see the unknown masses are placed on the left hand side of the pan. The standard masses are placed on the right hand side of the pan. You might have seen this sort of scale on vegetable shop and fruit shop. What they do is actually they put fruits. If you have asked them to weigh 1 kilo of apple, let's say, yeah, 1 kilo of potatoes. Okay, that would be much better. 1 kilo of potatoes. Then, and they do use some standard masses on the right hand side, and they keep on adding potatoes. And whenever the two pans are balanced, so it means that the weight that the mass that you have asked for is done, and they do hand you over. And weight, yeah, the weight is measured by spring balance. This is something new that you are looking at, and definitely when you be going to the physics lab, you will be taking weight of different objects. But for a little bit of yeah, just for a little bit of understanding, this is spring balance, and there is a pointer here, there is a hook, and you hang objects of uh, the object whose weight needs to be measured. You just hang it from this side, and this pointer over here is right now at 0, but when you hang an object, this pointer comes down, 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 and the scale over here represents the weight of the unknown object, the weight of the object that you have hung below vertically. Yeah, that is how you can find the weight using a spring balance. Mass is the measure of inertia of a body. Yes, greater the mass, greater the inertia. And weight is calculated by the formula. This is the formula. W is equal to m into g, where W is weight, m is mass, and g is gravitational acceleration. And value of g is 10 on surface of the earth. It is 9.8 when you go slightly above, like on mountainous areas, hilly areas, value of g is 9.8. And as you go further, suppose you are planning to go to the moon, your value of g will become 1.6 meter per second square. Yes, value of g decreases by 1/6 of the gravity of the earth. So gravity of the earth is 10, so you're on moon, it decreases by 1 by 6 times. So 10 divided by 6 is 1.6 meter per second square. And in space, value of g is 0. Mass of body cannot be 0. That's now true by definition now, and I hope you have a pretty much good idea of why mass cannot be 0, because it is the matter contained in the body, and it doesn't change. Matter doesn't change. Matter inside our body doesn't change. So that is why it cannot be 0. Weight of a body can be 0. Yes, it is possible. That is at the center of the earth and in space. G is 0. Yes, in space. See this astronaut, it's again floating in the air, and there is no effect of gravity. Yeah, in space there is no gravity. So value of g, you're going to put 0 when you're going to solve it. W is equal to m into g. Whatever the mass of this astronaut is, let's suppose it's 50 kg. So whatever number you multiply with 0, you know the answer is going to be 0. So the answer is going to be 0 Newton. So weight of the body in space can be 0. However, at the center of the earth, let's see. Okay, so let's suppose you are moving to the center of the earth. There are like three layers: crust, mantle, and core. This is the core part. So you are inside the earth at the core, at the center, and your weight would be 0 here. Why? Because you would be pulled equally by gravity in all directions. That is why value of g is going to be 0. So your home assignment is you have to revise the lecture and you have to write the differences between mass and weight. And please do solve the numericals 3.2 and 3.3 from page 83 in your copy. While solving the numericals, do keep in mind you have to follow the 4 basic steps: data, formula, solution, and result. 3.2, 3.3 are related to the problem related to the topic of weight. You will have to use the formula W is equal to m into g to solve them. My answer for the question that I asked during the lecture, I will be waiting for it. Do send me a screenshot of your work and do reply me soon, and we will be discussing this answer in class. And don't forget, when you're looking at the weighing scale, you know what units you are using with the value. So taking into consideration the unit, you will be getting the idea of what your weighing scale gives you, the mass or the weight. Good. Okay, so if you still have any queries, you can contact me on my WhatsApp number. Shared in group. Take care. Allah Hafiz.